Okay, so today's topic is free body diagrams. So please understand how to make free body diagrams. So in this question, if you'll see, we have one mass M1 here, one mass M2 here, and there is also one pulley P1. So this is pulley P1, this is pulley P2. So I'll explain how to draw free body diagrams. So first, let us suppose we draw for M1. So for M1, if you'll see, M1G will be there, that is gravitational force, and there is a string on the top of the M1, so tension will be T. So T and M1G will be there in the free body diagram. And remember a very important concept. See, from this point, so from initial point, like from this point to the final point, this full string is same. So this is only one string. So at all the points tension will be equal. So if pulley is massless, so if pulley doesn't have any mass, tension in string will remain same. So if here tension is T, then here also tension will be T only. So if we'll draw free body diagram of M2, so for M2, M2G will be downwards and T will be upwards. So this is how you have to draw free body diagram for M1 and M2. Now let's come to pulley P1. So this is our pulley P1. So for P1, if you'll see, there the string is downward also and this side also. So there will be two tension. So one tension will be downwards, that is T. Another tension will be on that side, that is tension T. And if you'll see, the pulley is connected to this straight rod. We don't know where the rod will apply force. So you can put reaction force R1 at any direction. It depends up to you because we don't know how much force this rod will put. So, but remember this thing. So suppose if we have pulley like this and a string is passing like this. So if I'll draw free body diagram, so I will put one T on downward side, one T on right hand side because the pulley is binded by this string on these two sides. Okay, so please remember this thing. Similarly, if I'll draw free body diagram for P2, suppose I draw for P2, so one tension will be this side. So if you'll see one tension this side, one tension will be downwards. So one tension will be downwards. Again, there's a straight road, so there will be reaction. So we don't know what will be this angle theta. You just have to put this reaction force. Okay, so let's take one more example. Suppose in this question, we have M1, M2, M3. So M1 and M2 are binded by one string. M2 and M3 are binded by another string. And there is another string here. So the strings are not same. So tension will be different. So for M1, if I'll draw FBD, so M1G will be downwards gravity. M1 is on a plane, so there will be normal force N1. And this pulley and this string will pull it on this side. So tension will be T1. Remember, normal is a push force, tension is a pull force. Okay, now for M2. If you'll see, M2 is also on this plane. So for this, the normal force will be N2. M2G will be their gravitational force. Now if you'll see, there is one string behind also and one string forward also. So this string will pull in backward direction. This string will pull in forward direction. So T1 will be backwards, T2 will be in forward direction. Remember, a string always pulls. And for M3, if you'll draw, so M3G will be downwards, normal will be upwards. So normal will be upwards, T2 will be backwards, and T3 will be in forward direction. So this is how you have to draw free body diagram for M1, M2, M3. Let's take one more example. Suppose in this question, suppose this mass is M1, this is M2. So first we'll draw for M1. So M1G will be there. No, there's no confusion about that, mass is there. Now if you'll see, this sphere is in contact with this here also and here also. So normal force will be perpendicular to the surface. So one normal force will be like this, so it will be N1. And from this side the normal force will be like this, so it will be N2. Please remember this point. Normal force is always perpendicular to the surface. So at this point the normal force will be on this side. Similarly for this M2, if I want to draw normal for this point, then just draw a tangent here and normal will be in this direction. So it will be N3, and from this side the normal will be in this direction. So it will be N2. Remember, this is Newton's third law that we'll discuss. So M2 will push M1 on that side and M1 will push M2 on this side. But two bodies will apply equal and opposite forces. So M2 will apply N2 on that side, then M1 will apply N2 on this side. So this is the FBD of M2, this is the FBD of M1. Please remember, suppose I draw something like this, and I'll put a mass here, and I'll ask how will be the normal force on this body. So you draw tangent here, so normal force will be something like this. If the body is here, and if I'll ask how will you draw normal force, so draw tangent here, so this will be normal force. So suppose if the body is here, so normal force will be like this, perpendicular to the surface. Suppose if I draw body here, so normal force will be like this. So normal is a push force, tension is a pull force. Please remember this thing. Okay, so a mass M is here, so you have to draw FBD for this. So mg will be downwards and normal force will be like this. So this will be N, because normal is perpendicular to the surface. So our surface is like this. So our surface is like this. So normal will be perpendicular. Okay, in this question, for this M, it's very easy. So mg will be downwards and there is a string. So tension will be upwards. If we'll see, this full string is same. So if here is tension is T, then here also tension will be T. So for this small m, mg will be there. The below string will pull downwards, so 1t will be in downward direction. And this string will pull in that direction, so 1t in that direction. And there is a horizontal road. We don't know how it will apply the force. So I'll just put an R. It depends on you where you want to put R. Because when we'll solve questions, we'll find the value of R. Okay. Okay, in this diagram, so there's a table on which there is a mass M and on that another mass M. So for this mass M, mg will be downwards, normal will be in that direction because normal will be that side. So N1 and mg, only two forces are there. For this M, if you'll see, mg will be there. This M is in contact with table also. So table will apply normal force N2 and this bigger M applied N1 on small m. So M will apply N1 on bigger M, Newton's third law. This M applied N1 on this M. So this M will also apply N1 on this M, but it will be opposite in direction. So forces will be equal and opposite in direction. So M has applied N1 on that direction. So M will apply force on this direction. So N1 will come here. So this is free body diagram of this plank and this small mass M. So now you have to submit one more assignment depending on this slide. But remember how to use Newton's third law. So suppose we have one mass M1 and another mass M2. So remember one thing, M1 will apply normal force on M2 in upward direction. Suppose this is N1, then M2 will apply normal force on M1 in downward direction. This will also be N1 only, Newton's third law. Okay.